basics for IIT Foundation. So with this, let's quickly go ahead and I'm going to introduce myself. So this is Trishita Majumdar and I'm a teacher expert at Cuemath. My teaching experience is 4 years and I'm a subject matter expert of mathematics and reasoning, and I teach students from India and US. Now let's look into the table of contents. So let's look into our table of contents for today's session. So we are going to understand number system, the applications of number system, problems. So the problems are going to be both basic and advanced level, and we are going to cover a wide variety of questions today, and we are going to look into our learning outcomes. So before I proceed further, I would want all of you to look into the definition of number system, and also if you think that you could define anything about number system, or if you think that there is anything which is related to this you are aware of, then you can put it up on the comment section. So let's quickly look here. A number system defines a set of values used to represent a quantity. The collection of numbers is also called as a number system. These numbers are of different types such as natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So these are all the types of numbers which we are going to cover up in today's session. We are going to have a quick brief on all of these, on what are natural, whole, integers, rational and irrational numbers, and we would be majorly focusing into rational and irrational numbers in today's class. Also, the other topic which we would be covering up is rationalization as well. So I would want all of you to stay till the end of the session, because all the grade 9s and 10 students, you all know that you have the topic of number system, that's real numbers, in your curriculum. So this session is also going to help you out a lot with your school curriculum, and along with that, it's going to help you out for Math Olympiad, and also it forms your base of IIT Foundation. So this topic is that important. Okay, so with this, let's proceed. Here goes our examples. So as everybody can see here, we have natural numbers which is represented by the letter n, and natural number always starts from 1. So we have 1, 2, 3, 4, 5, and it keeps going further. And then we have whole numbers next. Whole numbers is represented by a w, and whole numbers always starts from 0. So 0, 1, 2, 3, 4, 5, and it keeps continuing further. Integers are a set of numbers which consist both negative and positive numbers, including a 0. So you can see that negative, negative 2, negative 3, negative 1, negative 2, negative 3, till negative infinity with a 0. And then towards the positive side also you have 1, 2, 3, and it goes on till infinity. So this is what your integers is. Coming to rational numbers, which is represented by q, P over Q form. So rational numbers is very, very important to understand, which is the basic focus of our session for today. That is P by Q form, where P and Q are integers and Q is not equal to 0. So basically, we will be learning a lot of things related to rational numbers. How do we relate a rational number to fraction? What are irrational numbers? What are terminating decimals? And there are a lot of things which we are going to cover up. With this, let's proceed further. So here goes our natural numbers. So as all of you can see, all the numbers starting from 1 till infinity are natural numbers, as we just discussed some time back. That's 1, 2, 3, 4, 5, 6, 7, 8, and then it goes on till infinity. These numbers lie on the right side of the number line and are positive. We all know about it. Going ahead, coming to whole numbers, let's see what are whole numbers. Whole numbers are we already saw it in the last slide that it starts from 0, and it's very, very similar to natural numbers, except for the fact that it includes a 0 with it. Okay, so these numbers lie on the right side of the number line from 0, okay, and are positive. So including a 0, all the other numbers which are lying on the right side of the number line are known as whole numbers. Okay, coming to the next part, that is integers. Integers are the whole numbers which can be positive, negative, or 0. Example 3, 21, 0, minus 78 are all integers. So it covers both the negative and positive numbers with a 0. Okay. Coming to the next part, rational numbers. A number which can be represented in the form of P upon Q is called a rational number. For example, 1 over 2, 4 over 5, 26 over 8, etc. Now I have a quick question for all of you. Now, can I say that every integer is a rational number? Well, let's see who is going to comment on the comment section. Can I say that every integer is a rational number? Let's see. Any responses? Well, yes, every integer is a rational number because every integer that's existing can be represented in the form of q. P upon q, I mean to say. Okay, so I can say that, let's say 3. Okay, so I could say 3 can also be written as 3 upon 1. So whenever you just have a whole integer existing, basically integer existing, so you could just say that the denominator of the integer could be assumed to be 1, and therefore this could be expressed as p upon q format. And we know that as per the definition of rational numbers, any number which can be expressed in the form of p upon q is known as a rational number. Hence, every integer is a rational number. Okay, but is the other way around true? Is every rational number is an integer? Yes. Any guesses? Any responses on the comment section? Let's see. Is every rational number an integer as well? Yes or no? Yes? Basically, the answer is no. Why? Let's see here. Now, let's see, for example, if I look into this 4 over 5. So, as we all know, 4 over 5, when you actually evaluate it, you would be getting this as 0.8. And 0.8 is a decimal number. It's not an integer. So here itself, we could say that every rational number is not an integer, but every integer is a rational number. Very, very important fact. Okay. Next thing, can anybody tell me if 0 is a rational number or not? Yes. Any idea? Well, 0 is also a rational number. As I had already mentioned, that every integer is a rational number. Because when you have 0, you could also express 0 as 0 upon 1, which is basically a representation of p upon q format. Okay, I hope this was clear enough. Coming to the next part, that is irrational numbers. So let's see what's irrational number. A number is called an irrational number if it cannot be represented in the form of p upon q. For example, we have square root of 3, square root of 5, square root of 11. Any other responses or any other answers on what are irrational numbers? Yes, all of you can put it on the comment section. Let's see who gives the right answer. Yes. Well, yeah, we also have examples like pi. Pi is also an irrational number. Okay. So we can extend the definition of irrational number to a huge extent. But for now, let's just focus into the basics. The basic part of irrational numbers definition is that a number which cannot be expressed in the form of p upon q is known as a irrational number. Okay. All right. Now let's see what's next. Real numbers. Coming to real numbers. The collection of all the rational and irrational numbers is called real numbers. So this rational and irrational numbers together combined is known as real numbers, which is our basic focus for today's session. Real numbers are denoted by R. Every real number is a unique point on the number line, and also every point on the number line represents a unique real number. So it's a vice versa thing. So if every real number could be represented on the number line, so it's very definite that every point on the number line also represents a unique real number. Okay. I hope that's clear enough. Now let's quickly move ahead and look into what are terminating decimals, because this is something which you would be coming across in the questions today, and hence it's very important for all of you to understand the term what's terminating decimals. But before I go ahead and display it here, can anybody tell me what you understand by terminating decimals? Any responses? Okay, all right, let me quickly brief on this. If the decimal expression of a over b terminates, that is, comes to an end, then the decimal so obtained is called terminating decimal. For example, 1 over 4, which is 0.25. So it means that at some point of time, when you do the division, like 1 upon 4, we all know that 1 upon 4 gives us 0.25. Why is it ending at 0.25? Because at some point of time, you're getting the remainder to be 0, right? So whenever you get the remainder as 0, you stop the division at that moment. And every decimal number which stops with a remainder of 0 are known as terminating decimals. There are a lot of decimals which does not stop. For example, let me show you a very basic thing. For example, let's say we have 10 divided by 3. Okay, so all of you can try dividing this. So 10 over 3, so 3 times 3 is 9, and then we have 10.39, and then we have 10.39. So this will never come to an end. There would never be a situation wherein we could say that the denominator, that's the remainder, is 0, because every time you get the dividend as 10 and every time you get the quotient as 3. So this keeps continuing. There is no such condition wherein your remainder ends up with a 0. So such decimals are called, any idea? Well, now we are going to see. Basically, these decimals are called repeating decimals. Okay, so here we have an example. A decimal in which a digit or a set of digits repeats repeatedly periodically is called a repeating decimal. Here you could see 2 over 3. All of you could convert 2 upon 3 and see you would be getting 0.66666. Why do we say repeated decimals to these kind of numbers? Because if you notice, the number after the point is basically repeating, right? There is no change in the value. Same goes with 10 over 3. We had repeating numbers, we had repeating digits after the point, hence they are known as repeating decimals. Okay? Alright, so I hope that was clear enough. Now, let's proceed further and look into what is meant by rationalization. So, rationalization is again going to play a very, very important and key role in this chapter, and it's mandatory for all of you to understand this very well. The purpose of it, the way we use it, why do we go ahead with it, how do we use it in the problems, each and everything is important about rationalization. Okay, so carefully look into this and we'll see what is meant by rationalization. If we have an irrational number, then the process of converting the denominator to a rational number by multiplying the numerator and denominator by a suitable number is called rationalization. Okay, so as you all can see here that there's an example given, 3 over root 2. So what does this exactly mean is, we all know that having an irrational number in the denominator is not considered to be a standard form of representation, right? We always want to make our denominator radical free. And that's the reason rationalization comes into picture, which helps us to eliminate the radical from the denominator. And how are we going to do so? It depends on what is the denominator. Okay. Now, according to the example that you have here, 3 over root 2, you could see that root 2 when multiplied with something should give you a result which takes away the root. So you will not have to have any root in the denominator once you rationalize it. And we know that if I multiply the same number root 2, so if I'm multiplying the root 2 with denominator, I would also multiply root 2 with numerator. So this would give us 3 root 2 over, this is root 2 the whole square. And we know that root 2 the whole square gives us a 2. So all of you can see now our denominator is radical free, or you could say our denominator turned out to be a rational number. Initially it was an irrational number, now it's a rational number. Okay, so this is why we go ahead with rationalization, and hence it plays a very, very important role. Okay, I hope that was clear. Now let's see next. Laws of radicals. Laws of radicals is something which will help you to brush up on your exponents laws, because it's basically exponent laws and laws of radicals are very similar to one another. Okay, so everybody please focus. This session is kind of going to be a revision for your school curriculum, and people who are preparing for IIT foundations, do focus, because we are going to have quite good level of problems. And also for every other student who is learning it for the first time, I'm sure, I guess most of you have come across this topic in your school curriculums, at least on the laws of radicals, which is in a way the same as laws of exponents. So we are going to combine these laws of radicals with our rationalization and work on the questions. Okay, so let's quickly look into our laws of radicals. So let's see here. If a is greater than 0, let a be greater than 0 and it's a real number. Let p and q be rational numbers. Then we have a to the power of p times a to the power of q is equal to a to the power of p plus q. We have learned this basis being multiplied with different powers, the powers get added. Okay, a to the power of p, the whole power of q. So this is known as power rule, wherein the power which is outside the parenthesis and the power which is inside the parenthesis gets multiplied among themselves. So the overall power on a is a to the power of pq. Coming to the next one, a to the power of p over a to the power of q, which says it's a division. So we all know that whenever we have division of same base with different powers, the overall power on the base is nothing but the subtraction of those two. So a to the power of p minus q. So you can relate your multiplication and division law, or you could say product and quotient law. Okay, so these are the terms which is basically used for these kind of laws. So in case of multiplication or product of same bases with different powers, you add the powers. In case of division or quotient law, you always subtract the powers. Okay. Coming to the last one, a to the power of p times b to the power of p, which is nothing but, you could see that the power is same on both the different bases. So you can simply combine the bases, multiply them and put the whole power as p. Okay. So let's quickly look into an example. Simplify 36 to the power of half. So you can see that all of you can see 62 to the power of half is equal to, so any idea what is happening here? Yes. So all of you could see here that this could be written as, all right. So this had to be 6 to the power of 2, not 62. So this had to be 6 to the power of 2 times half is equal to 6 to the power of 2 times of half, which is equal to 6 to the power of 1, and that's equal to 6. Okay. So here what's exactly happening is, we had a 36 here, right? But we all know that we can also express 36 as a square of 6. So instead of 36, I have written square of 6, which is raised to the power of half. And according to the second law, we could multiply these two powers, 2 times half, which gives us a 6. Okay. I hope this was all clear to you. Yeah. Now let's quickly move forward. Here goes our next thing, applications. The most common application of number system can be found in computer technology. Useful for higher classes to solve advanced problems. Very, very necessary. I had already mentioned earlier that number system is going to form the basics for all the other chapters, and it's very, very important. Okay, so you cannot even think about skipping this topic. All right. And coming to the next one, real numbers helps us to count and to measure out quantities of different items. Very true. Numbers help us describe events and phenomena by equations and formulas. Okay, so these are a few listed down applications of number systems. Now going ahead, let's start with our problems for today. Okay, so we are going to have two kinds of problems. We are going to have basic as well as advanced, but trust me, the whole session is going to clear your concepts to a huge level, and you're going to have a very good practice. Now, as I had mentioned in the beginning itself, since this is a course which is related to your regular math as well as Olympiad and IIT Foundation, please sit with your notebooks and pens, because this is not going to work like aptitude. We will have to sit and solve and work out on problems, and also this is going to give you a very good revision for your school curriculum as well. And along with this, I also want all of you to comment on the comment section and let me know your approaches on how did you go about a question. And with this, let's begin. Which of the following numbers have terminating decimal expansion? So we just learned some time back what is meant by terminating decimal expansion. So terminating decimal expansion is something wherein the division comes to an end at some point of time with a remainder yielding to be 0, right? So that's what is our requirement here. So here goes our options. So all of you can see that these are the options: 8 over 225, 5 over 18, 11 over 21, and 21 over 150. Now, how would you basically understand whether the given fractions are terminating or not? Would you actually sit and divide all of them? Is that a good way of doing things? No, you shouldn't be going by that way. Trust me, that's going to consume a lot of time. We have a predefined rule for doing such questions, and the rule is, whenever you have these kind of fractions given to you, wherein you have to state whether the fractions are terminating decimal or not, you will have to look into the denominator, you have to prime factorize it, and you'll have to see if your denominator is of the form 2 to the power of m times 5 to the power of n. What do I mean? I mean that you need to have 2's and 5's in the denominator. If so, that means that fraction is a terminating decimal. Okay, why so? Many of you must have this question in your mind. Why is that so? Why is it that we are just looking for 2 and 5 and not any other number? Well, before I explain the reason, I want all of you to think about it and give your comments on the comment section. Till then, let's start solving. Now, knowing the method, let's start with our first denominator. So I'll quickly write down here. So we have 225 as the denominator here. Let me factorize this. We know that 225's factorization is 225 is 15 squared, right? So I can simply write this as 15 times 15. But since I told this has to be a prime factorization, so this would become 3 times 5 times 3 times 5, which is 3 squared times 5 squared, right? Yes, all of you clear with this? Okay, so this is the first one. Now, before I write down any answer, I'm just going to quickly write down the, write down the factorization of all the denominators. Coming to 21. So, as you all can see, 21 can be written as 7 times 3. Okay, coming to 18. 18 could be written as, so we know that 9 times 2 is 18, or you could also say 3 to the power of 2 times 2 is 18. Coming to 150, 150 is nothing but, it's nothing but 30 times 5, right? 30 times 5, which could also be written as 3 times 10 times 5, which could also be written as 3 times 2 times 5 times 5, right? Now, before I proceed with this, I want all of you to observe the denominators very well and answer me that which among the 4 options is going to give me a terminating decimal. Let's see who gives the answer first. Let me just wait for it. Any responses? Any responses on the comment section? Okay, now knowing the rule, let me again write it down. The denominator should be of the form, the denominator should have the factors 2 to the power of m times 5 to the power of n. This is a mandatory condition. Only then I could say that a fraction is a terminating decimal. So out of option A, B, C and D, I can see this does not have a 2. This does not have any of these. This does not have a 5. But this does have 2 and 5. So 3 times 2 to the power of 1 times 5 to the power of 2. So I could say, as per the rule, option D is a terminating decimal. You in fact could go ahead and check with it. So let me also show you. I'll verify and show it to you. 21 upon 150. So let's first actually make it to the lowest form. So 3 times 7, 3 times 5, 7 upon 50. So let me show you 7 upon 50. So this is 0. And then we have a 70. So 50 times 1 is 50. And then we have 200. Yes, and 50 times 4 is 100. 200. So therefore, your remainder turns out to be 0. So we know that this gave us an equivalent of 0.14. So it's a terminating decimal. But the question is, why is it that we check factors of 2 and 5 in the denominator? Let me tell you. The reason is every number is divisible by 2 and 5. Okay? Every number you take is divisible by 2 and 5. Okay? You can yourself take any number as an example and check whether it's divisible by 2 and 5. And if you have 2 and 5 in the denominator, that means I could say that at some point of time, the division is definitely going to end because 2 and 5 is dividing the number, dividing the numerator. Isn't it so? Isn't it so? Like for example, let me just show you a very basic thing with respect to this itself. So as you can see that 21 was divisible, divisibility was supposed to be checked by 15. But now I'm just considering 2. So let me check if 21 divisible by 2 is giving me a terminating decimal or not. So 2 times 10 is 20 and then 2 times 5 is 10. So yes, as all of us can see that this does gives us a terminating decimal. Try it out with 5. 5 times 4 is 20 and this gives us 4.2 as the result. So from here, what can we conclude? The conclusion is if your denominator has both 2 and 5's as the factors, then you can definitely say that your division is going to end. No matter whatever you have apart from 2 and 5, all these becomes multiples of 2's and 5's. So it's very obvious that if there is 2's and 5's in your denominator, your division ends. Why does it end? Because every number is divisible by 2's and 5's. So if a division is ending, that's what we want. That's what we want. When a division is ending, it's known to be terminating decimal. Okay. I hope I was clear enough in explaining this particular reasoning behind taking 2 to the power of m and 5 to the power of n in a very simple manner. Okay. I also took 2 examples and showed it to you. Why is it happening so? Okay. So you all can take your own examples and try to verify this. Alright, so this is one pattern of the questions which is being asked, and it's very, very important. Do not go by the conventional method of dividing everything and checking. You will not be able to solve it quick enough. So if you notice, the factorization method gave us the answer very quick. Okay, now let's proceed further. Here goes our second question, and let's see who gives the answer. So before I put down the options, let's just look into the question. 2 to the power of x minus 3, this dot signifies multiplication, times 3 to the power of 2x minus 8 is equal to 36. Then the value of x is how much? So this is something which is related to powers and exponents. And if you've already solved it, here goes your options. If anybody wants to give the answer on the comment section, please do put up your answers on the comment section. Okay. And now let me quickly solve this up. So 2 to the power of x minus 3 times 3 to the power of 2x minus 8 is equal to 36. Now as all of you can see, 2 to the power of x minus 3. Can I separate out these terms? I can definitely separate out these terms. I can also write this as 2 to the power of x times 2 to the power of negative 3 times 3 to the power of 2x times 3 to the power of negative 8. The reason I could separate it out is because we know that when we have same base with different powers, they get added up. So see here, we are just doing the converse of our product law, okay, which is equal to 36. All right. Now, if you all notice, these two are negative powers. So we have a law of exponent which says that a to the power of minus x can also be expressed at 1 over a to the power of x. So this means that I have a negative power here, and if I have to convert it into a positive power, I'll have to take the reciprocal of that particular number. So let's do that. So we have 2 to the power of minus 3. So that would become 1 over 2 to the power of 3. So 2x times 3x, 3 to the power of 2x, divided by, so since these two have negative powers, these are going in reciprocal and it turns out to be positive using this law of exponent, okay, which is equal to 36. From here, what can we say? We can say that 2 to the power of x times 3 to the power of 2x is going to give us, we would be taking this denominator to the other side, that is 36 times 2 to the power of 3 times 3 to the power of 8, okay. Now what do we do is, you need to find the value of x, and it's only possible to compare the value of x if the whole of your right hand side could also be converted in terms of 2 and 3. That means you need to change the base of 36. So when you factorize 36, what do you get? I can do it in my mind. Try doing things in your mind. 36 is 9 times 4. 9 could be written as 3 to the power of 2, and 4 could be written as 2 to the power of 2 times 2 to the power of 3 times 3 to the power of 8. So from here, you could see that we could combine these common bases, that is 2 squared times 2 cubed, and this is 3 squared times 3 to the power of 8. So from here, what do we notice? This would apply the product law, which is 2 to the power of 2 plus 3, 5, times 3 to the power of 2 plus 8, which is nothing but 10. And the LHS is 2 to the power of x times 3 to the power of 2x. So definitely we can now go ahead and compare these bases and these powers. So from here, if you notice, the value of x is 5. Even if you want to go by this way, you could check 2x is equal to 10. So x would be equal to 5. I hope that was clear and everybody were able to solve it. This was clearly based on the concepts of exponents. So if you have a good handling power of laws of exponents, I'm sure that most of you could actually reach the answer before I solved it. Okay, so here goes our next question. Express the mixed recurring decimal 4.32 in the form of P over Q. So 4.32 and the bar is only on 2. What does this bar indicate? The bar basically indicates that the 2 is repeating. The whole of 3, 2 is not repeating. Only the 2 is repeating. Okay. So let's quickly notice what's going to happen here. So here are the options. If any of you have solved it, then you can go ahead and you can give your answers on the comment section. And for everyone else who is looking into this question, I'm sure that you guys are able to relate it with your regular math curriculum because you've been doing such kind of questions in your school math. So I want all of you to be quick enough to respond, and please put up your approaches on the comment section as well so that the others also could get some help from all of you. Okay. All right. So now let me show you how do you work on such kind of questions. So we have 4.32 and 2 is the recurring part, and I'm going to assume this as x. One major thing which you need to know here is you have to get rid of the you have to get rid of the terminating part so that you could convert it into a fraction. You cannot have the terminating number keep on repeating in your expression, otherwise you will never end up getting a fraction. And to do so, what am I going to do? Let me show you something. Now, if I multiply 10 on both the sides, that is 10 times 4.32 bar is equal to 10x, what am I going to get? I am going to get 4.32. So this point shifts by one place. I get 43.2 bar, right? 43.2 bar, which is equal to 10x, okay? I'll tell you the reason why I did multiply it with 10. Now carefully see, everybody carefully notice, if you now subtract 4.32 bar from 43.2 bar, are you able to eliminate this repetitive 2? Is it possible? Or are you able to eliminate this whole decimal part? Give me the answer on the comment section. Also, let me show it to you what I meant to say. I meant to say if you're going to subtract this and this, 10x minus x, which is 43.2 bar minus 4.32 bar. Okay. So we know that 43.2 bar is nothing but 43.2222 and so on. And 4.32 bar is 4.3222. So you still end up getting some decimal number after the point, right? And I am trying to actually get a 0 in the decimal part. I do not want any decimal part. I just want a whole number. So basically subtracting 10x and x is not helping me out because here you have a 3 and here you have a 2, which does not cancels out to 0. So what do we done in this case? Let's do another thing. Let's go ahead and multiply this with 100 as well. So 100 times of 4.32 bar is equal to 100x. Now what's this going to result to? So 4.32 bar, 2 places shift. So this is going to give me 432.2 bar is equal to 100x, correct? Now if you all see, if you subtract this number 432.2 bar and 43.2 bar, you can see that after the decimal, both of these has 2 bars. We actually got rid of this 3. So they will anyway subtract and the decimal point, the decimal digit turns out to be 0. And that's what our requirement was. So can I take this as equation 1 and can I take this as equation 2 and shall I subtract them? Yes, we can do it. So 100x minus 10x is equal to 432.2 bar minus 43.2 bar. So everyone who has used x and 10x, I told you the disadvantage that you are not getting rid of the decimal part which we actually want to get. So the question becomes easier. Okay. So from here I can see I get a 90x which is equal to, see when you subtract this, the 2 bar, 2, 2, 2, 2, 2, 2, 2 and here 2, 2, 2, 2, 2, everything gets cancelled. So we just have to subtract 432 minus 43 which gives us a 389. Therefore this x turns out to be 389 upon 90. And see, x was what? X was this decimal itself and now x has got converted into a fraction of p over q, which is option A. I hope the question was clear to all of you. So we are also going to do such kind of questions further in the session. Please stay tuned. And if any of you did not understand, please do watch the recording once again and put up your queries on the comment section. We'll get back to it. Okay. So with this, let's proceed further. So here goes our next question. Rational number minus 18 over 5 lies between consecutive integers And the consecutive integers given are this. I think this is going to be like one of the most easiest questions for a grade 9th and 10th student. I'm sure enough. So let's see who gives the answer on the comment section. I want maximum responses for this particular question because this is a very, very simple question. Very easy. Any answers, anybody? All right, let's see here. Let's also notice this, okay? So rational number minus 18 over 5. Can we first divide this 18 over 5 and check its decimal form? So let's do that. 5 times 3 is 15 and then we have 3 and then 0 coming in. So 3.6. So since it's a negative 18 over 5, so we'll take this as negative 18 over 5 can also be expressed as negative 3.6. And it's very obvious if you think about this number, between which two numbers is it lying? It has to be between minus 3 and 4, right? You can think about a number line representing minus 3.6, which is definitely going to lie between minus 3 and minus 4, okay? All right, so good job to all of those who has given the right answer on the comment section. Keep commenting, keep giving your approaches. It's not always about the answer, but it's also about the approach, how you go about it, okay? All right, let's quickly look into our next question. So here goes our next question. I want all of you to analyze this and then I will be displaying the options soon enough. Okay, let's quickly have a look into this question. If x is equal to 1 minus root 2, then find the value of x minus 1 over x the whole square. Okay, so let's see how do we go about this question. And here goes our options as well. If any of you have solved, you can put it on the comment section and also the way you've done it. It's a very interesting question. So let me quickly go ahead with it. Okay. So x is equal to 1 minus square root of 2. And our requirement is we have to figure out x minus 1 by x the whole square. So to get the term 1 by x, we'll have to take the reciprocal of x, right? So if I take the reciprocal of x, what do I get? I get 1 over 1 minus root 2. And from here, what I can say is root 2 is a irrational number. So I have to rationalize it and make it a rational number. So I'm going to do 1 plus root 2 to this. And I'm going to multiply 1 plus root 2 to this as well. Okay. So from here, I notice that I get 1 plus root 2 over this forms the identity a minus b times a plus b, which is a square minus b squared. So 1 square minus root 2 the whole square. And from here, I get 1 plus square root of 2 over 1 minus 2. Right? So this gives me a negative. So there's a negative 1 in the denominator. So minus of 1 plus root 2, which is equal to minus root 2. Sorry. This is going to give me a, yeah. So minus of 1 plus root 2, or you could say this is minus 1 minus root 2. So let me just keep it like this. Okay. So we have got the value of 1 over x. Now what are we going to do? We are going to now substitute the value of x and 1 over x in our expression. So x minus 1 over x the whole square. So we know that the value of x is 1 minus root 2 and the value of 1 minus x is minus of minus 1 minus root 2 the whole square. And from here I could say this is 1 minus root 2. Minus and minus gets converted to plus. And this minus and minus gets converted to plus root 2 the whole square. And you could cancel out these minus root 2 and plus root 2. So we have 1 plus 1, which is 2 the whole square. And that's nothing but 4. So hence option C is the right answer, which is nothing but 4. I hope the question was clear to all of you. Now with this, if there's any doubt anybody is facing, then you could let me know. Now many of you must have thought about this question in this way. Why is it that we are rationalizing 1 over x and why cannot we directly substitute the reciprocated format in the expression? You can go ahead and try that out, but that's going to be complicated again. All right. So it's better, I would, according to my suggestion, you could always rationalize this and then substitute it in the expression. It's going to be much more simpler. All right. Now, let's go ahead. So here goes our next question. That's the advanced level question. So I'm sure that most of you are able to relate these kind of questions to your regular curriculum. So hence I told you that it's very important for you to revise on your basics and improve on your foundation. Okay. So let's quickly notice this. The value of this whole thing is equal to what? And here goes our options. So there is a particular way to work on these kind of problems. It looks very complicated. It looks like you have to do a lot of work, but trust me, it's just a pattern. Once you understand the pattern, it's just a cakewalk. Okay. So now let me quickly show it to you. How do you go about this question? By taking few terms initially. So 1 over 1 plus root 2. And as I told you, whenever you have such kind of term, we are going to rationalize them. Okay. So let's rationalize them. 1 minus root 2. And here also we have a 1 minus root 2. So this gives a 1 minus root 2 divided by 1 square minus root 2 square gives us a minus 1. So this in a way gives us minus 1 plus root 2. So our first expression became minus 1 plus root 2. Coming to the second expression, that is 1 over square root of 2 plus square root of 3. So to get rid of the roots here in the denominator, I'm going to multiply it with its conjugate. So square root of 2 minus square root of 3. So from here I could see that square root of 2 minus square root of 3 divided by, this would become 2 minus 3 because square root of 2 the whole square is 2 minus square root of 3 the whole square is 3. So 2 minus 3, which is again going to give me a minus 1, and I can take this minus on top, and this again gives me minus root 2 plus root 3. Okay. Now let me solve on the third term and show you. The third term is 1 over root 3 plus root 4. So this being multiplied with root 3 minus root 4, that's the conjugate. And this also is root 3 minus root 4, which is going to be equal to root 3 minus root 4 divided by, this is going to give us a 3 minus 4 again. So 3 minus 4 is minus 1 is equal to, so minus goes on top, minus root 3 plus root 4. Now everybody carefully observe what's exactly happening. No matter whichever term you take out of the first three, you always end up getting a minus 1, right? And what's happening to the actual expression? If you have a 1 plus root 2, there is a inclusion of negative 1. So it is changing to minus 1 plus root 2. Similarly, for the second term, if you notice, root 2 plus root 3 changed to minus root 2 plus root 3. So root 3 plus root 4 changed to minus root 3 plus root 4. We have got a pattern to this. So it's very obvious that we can easily tell for the fourth term without even solving this that it's going to be minus root 4 plus root 5, minus root 5 plus root 6. Okay. Now knowing this fact, let's substitute all of these. Okay. So here goes our substitution. Carefully notice, I want all of you to be attentive. So the first term we know that was minus 1 plus root 2. The second term became minus root 2 plus root 3. The third term became minus root 3 plus root 4. The fourth term would become minus, so it would become minus root 4 plus root 5. The fifth term would be minus root 5 plus root 6. Then it would be minus root 6 plus root 7. And then we have minus root 7 plus root 8. And then we have minus root 8 plus root 9. Okay. So from here, what can we say is, we have all of these terms which are cancelling out each other. So this was actually a root 2. So plus root 2 minus root 2 cancel, root 3 minus root 3. So if you notice, all of these are cancelling out each other. The only term we are left out with a minus 1 and a root 9. So can I say this is nothing but minus 1 plus root 9? Yes. So which is nothing but equal to minus 1 plus root 9 is 3, and that's going to be equal to 2. Okay. I hope this was clear enough to all of you. So this answer is option C, which is 2. Okay. So whenever you have such kind of questions, do not solve all the terms. It's just going to be time consuming. Just notice each and every term and try to develop a pattern, because once you develop the pattern, it's going to be very, very easy and it's not going to consume a lot of time. All right. So with this, we are going to go ahead with our next question on advanced questions. The rationalizing factor of this particular expression is what? Okay, so this is a pretty good question, and there are a lot of students who also get confused with such kind of questions, I'm sure. All right, I'm going to tell you a very good method to this, so do not worry. So here goes our options. All of you can try working it on your notebook and let me know what is the answer all of you are getting. So let me solve this first. So what am I exactly going to do here is, I'm going to write this in a different way. Okay. When I say a different way, it basically means that we all know that if I have square root of, let's say, some number x, this could also be written as x to the power of half, right? If I have, let's say, cube root of some number y, this could be written as y to the power of 1/3. So similarly, if you have 7th root of this whole thing, I can write it as this whole expression to the power of 1/7, right? I can definitely do that. So I'll write this as x cube, y to the power of 5, z to the power of 2, the whole power of 1/7. And from here, we already know that according to laws of exponents, if we have all these three to the whole power of 1/7, this power gets multiplied to each of the variables powers, right? So I can say this would become x to the power of 3/7, because 3 times 1/7 is 3/7. This would become y to the power of 5/7, and this would become of z to the power of 2/7. Okay. Now carefully see. If you have to make this, what do you mean by rationalizing factor? A rationalizing factor of a number is something which, when multiplied to it, actually makes the number a rational number. Because currently the number that we have is an irrational number. So we have to figure out one such number which, when multiplied to this given expression, makes it a rational number. Okay. And to do so, what am I going to do? I'm going to consider the terms individually. X to the power of 3/7. Now, if you want to get rid of this 3/7, basically 7s, right? Because you know that x to the power of 3/7 can also be written as in this way. X cube, and this is the 7th root, which is an irrational number. And we don't want this to happen. So if you do not want this to happen, what am I going to do? I am going to think about multiplying such a number with it so that this power turns out to become a whole number. And for that, what am I going to do? I am going to think about something. So if I multiply this with x to the power of 4/7, what happens? We know that this is the product law of exponents, that is two different bases of different power, two same bases with different power basically adds up the power. So from here I could say this would result to 3 plus 4, which is 7/7, and this gives us a 1. I hope you all were clear with this. And now the question is, how did you understand you have to choose a 4? Because I know that the denominator is 7, and if I have to cancel out that 7, then on the numerator also I need to have a multiple of 7, correct? Yes, so the minimum multiple of, the least multiple of 7 is 7 itself, and to get a 7 in the numerator, I need to add 4 to 3. Hence, I chose this, okay? So according to this, let's go ahead with the next one, x. So we have y to the power of 5/7. And we know that 5 plus 2 gives us a 7. So this has to be 2 7s, right? So this gives us, y to the power of 7/7, which is nothing but y to the power of 1. And the third one is nothing but z to the power of 2 7s. So with 2, I need to add a 5. So z to the power of 5/7, which is equal to z to the power of 7/7. So it's giving us a z power 1. Now, if you notice, the combination of these three became x, y, z, which is a rational number. So what is the multiplying factors? This was our first multiplying factor. This is our second multiplying factor. This is our third multiplying factor, which is the rationalizing factor for this. So let me combine all the three. X to the power of 4/7 times y to the power of 2/7 times z to the power of 5/7 is equal to, you could take x to the power of 4 times y to the power of 2 times z to the power of 5, the whole of 1/7. And this is nothing but, this is your 7th root of x power of 4, y square and z 5, right? And as per option A, B, C and D, option A is the right answer. Okay, so I hope you found the question very interesting. Now, so if any of you have any queries, please do put it up on the comment section. And this is going to be our last question for the day, and we are going to wind up the session after this. Okay, so let's see about this. The number x is equal to 1.242424 can be expressed in the form of x equal to, this is going to be p upon q, where p and q are positive integers having no common factors. Then p plus q is equal to how much? Okay, so as you all know, we had done similar kind of questions some time back, right? So if you actually have to express this in the form of p upon q, you have to use the multiplication of 10x, 100x, the question that we had done. How do we convert a terminating decimal to a fraction, right? So that was the question. So this is also very similar. Now let's try to multiply 10x to this. So this would give us 12.42424, right? So this would give us a 12.424. When I subtract 10x and x, you can notice that here you have 4 in the first decimal digit, you have a 2 here. So you're not going to get rid of the decimal digits if you subtract 10x and x. So let's go ahead with 100x now. So when you go ahead with 100x, it is 124.2424 and so on. Now the question is, would you be choosing 100x and 10x? Again, it doesn't work because 4 and 2 are again not giving us a 0, right? But we can definitely choose 100x and x. Why? Because see, the first digit after the decimal is 2, and here in case of 100x also, the first digit after the decimal is 2. So when we are subtracting this 100x minus x, this would give us 124.2424 minus 1.2424. So as you can see, this 2424 and 2424 are all going to be cancelled out, and we are going to have 124 minus, so what are we going to have here? 124 minus 1, which is going to give us a 123. And 100x minus x is going to give us a 99x. So from here, x is equal to 123 upon 99. So from here, let's simplify this. So this is 3 times 4 is 12, and this is 33. So I could say that our p upon q is 41 upon 33. So can I say my value of p is 41 and value of q is 33? So if I have to find the value of p plus q, then it's going to be 41 plus 33, which is equal to 74, p plus q. Hence, the answer is 74. And here goes our options. So let me clear it up. Here goes our options, which is nothing but option B. I hope this is clear enough. I'm sure that all of you must have enjoyed the session, and there are a lot of students who might have also found this complicated. Do not worry. Things would come with practice. Okay. So with this, let's quickly look into the learning outcomes. So here, as we can see, that we have understood the concepts and the problems. We have understood how to perform the operations on numbers and various properties used in numbers. Okay. And then coming to the next part, that's the TUCO Olympiad exam. So as we all know that Cuemath has launched the TUCO Olympiad exam. So all of you can go ahead and register for the exam, which is going to be held in the month of December and Jan. The link would be provided in the description box, and you would all get a real-time experience to the examination, and along with it, you would get a course curriculum of rupees 5,000, which is completely free. And all of this just for rupees 200. So do not delay. All of you go ahead and register, and if you did like this session, please hit on the like button and share it with your friends, and also you can put on your feedbacks and comments on the comment section. So see you in the next session.